In this video, I'm going to go over one of our newer post-processing tools within HyperView called HotSpot. I'm starting with a stiffened panel. Each of these four panels has a different thickness, and I've got 1Ds out of all the intersections. I've applied a couple static loads just to some various spots so I can get some cluster hotspots. So I've ran this in OptiStruct as a linear static model, and I've got my results on this other window in my other page here. I'll go ahead and maximize that to look at this one. So this is kind of what we would expect. Got some different clustering. Our thinnest panel has the highest stresses, but our other panels do have some hotspots as well. In the results ribbon, we're going to go to the hotspot tool. The hotspot tool works on whatever you have contoured. So right now I've got element stresses, von Mises contoured. And when I go into this, the first thing I have to do is go into the search criteria or go into the hamburger menu. I can go and set my default. This is kind of what you'd be starting with. As we kind of walk along, the first tab has all your search criteria. Second tab has preferences just on the visualization. So numeric precision, numeric format, note, type, just visualizations. Search criteria is what you define for all your different filters. First thing is selection. If you don't select anything, it'll automatically grab everything in the whole model. In my case, it's just these four panels, but a lot of times you do want to know your highest stresses in your whole model. You can also grab them individually by component, by element, or material or property. Next option is the value, the result value filter. So you can do a greater than, less than, within range, out of range, and that's working on the contour value. Then you have the hotspot separation. So that is the distance between the highest values in that cluster. We're going to play with that value because this is kind of an important thing to recognize and know for finding these different areas and what you actually want to find as a hotspot. And then we have number of hotspots. That's just the value, top value, bottom value, top and bottom, or we can turn it off. Search load cases, current, all, kind of depends on what you're doing. If you're doing an envelope plot, something like that. And then there's some advanced options that we'll actually get into a little bit here. So I guess the main one that you would probably use just right off the bat is let's find just the top one, the greatest value, the max value in this contour, which in our case right now is stress. If I say find hotspot, I say has found one, and I can say review. And that makes sense. So it's value of 322 in this panel 1. That's our thinnest panel. And you can see in our contour, that's our max value right here. Now, once we've found it, all we've really done right now is found this value. What we can do here is then review these results, keep these results, share these results, however you want. So if you go to the review results, you get a ranking. For our case right now, we just have 1. That's pretty easy to see. And then we can create a note. That's going to create on top of that value just the exact note that we've already seen. But what's nice is this stays. So we get to keep that note for all of our different types of post-processing. Because otherwise, when we exit this tool, this goes away. This is linked right now to the hotspot tool. So once we exit this or we do another hotspot search criteria, we lose this. So we need a way of keeping that. That's also why it's important to label your queries nicely. The other one we have is a measure. If you've worked with this before, measures just grab the value or the contoured value of what you have. What's nice about this is you can use it for other things, such as live linking or things like that through hypergraph, but it is linked to this current contour. So if you were to change the simulation, change the result type, that value is kind of no longer valid. It's linked or it's attached to that entity, in this case, that element ID. You can create a set, and you can export to a CSV file. So that's kind of probably the simplest one, is let's just find the hottest spot in the whole assembly, the whole model. Now, some other ones we might want to do is, okay, well, what about, I have 4 different panels here. What if I wanted to find the highest value for each panel? Well, that's where we can go down to this advanced option and say output per component, and then say find hotspot and review. So now I've got that same value in that one panel, the thinnest panel. And then if I go to the next panel, 2, we find our value there, panel 3 at the edge, and panel 4 at the other edge. So that's the hotspot per component. And what we can do is we can export these. These are nice to be able to export or save. They're just simple XML files, and it keeps all your search criteria. So I can bring one in that I have previously. This is for everything over 100. So it's gonna look at my whole model, and it's gonna use a value filter of greater than 100. So, you know, anything above probably this light green or yellow in here. And then this hotspot separation is still at 10. So anything closer than that 10 or further away from than that 10, it's going to tag. And I have my number of hotspots disabled. So based on how many I have, it could be hundreds or it could just be a handful. So if I go and say find hotspot, you can see that I've got 6. And these are all my elements in my whole model that are above 100. And this is where we're going to start talking a little bit about what do you consider a hotspot and a cluster. Because if you look at this, it's really only pinging one value, and it's pinging it outside of a certain value. So it's distanced away from here, and this one isn't getting pinged at all, and then this one. So what is your hotspot value? What is your definition of a hotspot? Is this whole area one spot, or are there 2? So we can kind of dig in a little bit deeper into that. And I've got another config file here, and this is over 150. And I've got my hotspot separation a little bit lower. I've got it down to 3. And I'm only doing it for one component. So if I say find and review, I've got my... Now you can see that I've actually only I have 3. These 3 are getting linked. And that's because I have, and the value 3 is directly related to this element size. So each of these elements are about 1. So this value here isn't grabbing anything outside of here, and this one here isn't grabbing it here. So if I were to rerun this and say 10, find, now I've got it just to 2 hotspots. I've got this one and this one. So how you want to determine what this clustering is kind of up to you. You know, if you want to just get the highest value of this whole group of elements, you can do that. Or if you want to consider each of those individual, you can do that. And that's based on this separation. So kind of number of different ways of doing it. Finding anything above a certain value outside of a radius, like a search radius, or just finding a top value. Just find the top three. I don't care what the threshold is. Like this one right here. This one's 62. It did not fall above our predefined range previously, but maybe I just want the top three. So you have a lot of different flexibility with using the hotspot tool, and especially the ability to save them and use them how you want.